All right, so we are going to review slope of a line. So slope is a number that describes both the direction and the steepness of a line. So slope can have one of four directions. So positive or negative. So positive would look like it's going uphill, and we determine that as we move left to right as the x numbers grow on a graph, and then downhill we're going down as we move left to right on the graph. And then we also have special cases of horizontal lines and vertical lines, and they have kind of special slopes. So to calculate the slope of a line, there are multiple ways we can think about that calculation, but they are really all doing the exact same math. So we usually use the letter or the variable m to represent slope in the math world. So slope is the ratio. So we divide the change in my y values over the change in my x values. Another way we might see that written is that change in phrase is sometimes used by this little triangle symbol called delta. So this means change in y over change in x. And then if we look at the graph, sometimes we use the phrase rise over run. So the rise is the change in the y values. So when I look at like this y coordinate and this y coordinate, that difference is my rise, and then my run is my change in x values. So the difference between that x coordinate and that x coordinate is my run. I can also calculate the rise and run values if I just have coordinates by taking a y coordinate, subtracting the other y coordinate, and then the x coordinate divided by the other x coordinate. All right, so these all mean the same thing. It's just different ways that we might think about it. So what we are going to focus on with slope in geometry right now is understanding if lines are parallel to each other by using their slopes or perpendicular to each other by using their slopes. So if we click this little Desmos link, so I graphed some lines, and then you can mess around with this to kind of get an understanding yourself, but I'm going to just focus on the blue and green lines. So notice how no matter how much I zoom out or change, those lines are never going to intersect. So the blue and green lines are parallel. And then if we remind ourselves about linear lines and the different pieces of it, so this number here, the 5, -2, those are the y-intercepts, 5 and -2, and then my coefficient on x, or that number in front of x, the -3, that's my slope. So we can see here that when lines are parallel, they are moving or increasing at the same steepness, the same slope. They have the same rise over run. So go back to notability. So if lines are parallel, their slopes are equivalent. Okay, they have the same slopes. They would have different y-intercepts or be different spots on the graph, but their slopes are the same. Okay, and then if I go back to my Desmos link, so we have, so the blue and green are parallel, and then I'm going to isolate, let's see, the purple and green. All right, so the purple and green lines are intersecting, so they cross each other. But now if we're trying to determine perpendicular, we have to be careful that perpendicular only means intersecting at a perfect right 90-degree angle. So I know on Desmos it's hard to completely verify. We can't normally have a protractor, a way to see that what these angles are. But I can tell from the slopes of the slope of -3 and the slope of 2/3. That's what we're going to use to determine mathematically if two lines are perpendicular or just intersecting. So these lines are just intersecting versus these two lines, the purple and orange, these intersect at 90-degree angles. And I know that from looking at the slopes, they are first opposite signs. So this slope of 2/3 is positive, this slope of -3/2 is negative, and their rise over run are flipped. All right, so 3/2 versus 2/3. So when we have that reverse rise over run, that's how we mathematically verify that two lines are perpendicular or meet at 90 degrees. So if lines are perpendicular, their slopes are, and so mathematically we'd say they're opposite reciprocals. So reciprocal. So a reciprocal would mean, so like 2/3, that reciprocal is 3/2. And so opposite means positive or negative. So one's positive, one's a negative slope. And reciprocal means we reverse. In this case, we think about reversing the rise and run. So you just flip that slope around. All right, so if I can verify that those slopes are opposite signs and the rise and run are reversed, then I know that they are perpendicular and they meet at 90-degree angles. So this information is what we're going to eventually use to help us classify quadrilaterals on a graph. So using those definitions of and properties of quadrilaterals, we can then verify if we have parallel lines or right angles using slopes. So first example, just practicing calculating slope. So this is line B. I can find my slope and I have 2 points marked here for me. So you want to have 2 nice points. And then we can make a slope triangle. And remember, we always want to be checking direction and steepness. So I would first verify if it's a positive or negative slope. So as I'm moving left to right, as my x values grow, this line is going uphill. So I know this is going to be a positive slope. So just kind of make a habit of verifying that first. And then when I make my slope triangle, my rise is 1, or my change in y values, and my run is 2, or my change in x values. So over here, my slope m is rise over run, which was 1/2. And it's positive, so I just leave it 1/2. If it was negative, if it was sloped this way, I would make it a negative value. All right, so then we're going to draw a new line that is parallel to line B and has a y-intercept at -4. So y-intercepts are where my graph crosses the y-axis. So 1, 2, 3, 4. So that's a y-intercept of -4. And then if it's going to be parallel, it's going to have the same slope. So since line B had a slope of 1/2, my new line, I'm going to call this line G, has a slope of 1/2 also. So that means I'm going to have a rise of 1 and a run of 2 to connect my next point. And then I would be able to keep on going up 1/2, and we can reverse that. So this is line G, and that should be parallel to line B. They will never intersect. And then we'll make another line that's perpendicular to both those lines. Okay, to be perpendicular to both the blue and green lines here because they are parallel to each other. And goes through the point -4, 5. So -1, 2, 3, 4, 5. All right, so if my line is perpendicular, then its slope needs to be the opposite reciprocal. So I need to make it the opposite sign and reverse my rise over run. So since my original lines were positive, this slope needs to be negative, and then I'm going to flip the rise over run to -2/1. So then from this orange point here, I can make sure, so making sure it's negative, it's going to go this direction. So it'll have a rise of 2 and a run of 1 sloping downhill. So 2, 1, down 2, 1. So this orange line here, because its slope is the opposite reciprocal, I know that it's meeting both of these lines at 90-degree angles. So this was line W. All right, So that's a little review of slope and then understanding parallel and perpendicular slopes. So examples of how we will use this will be determining if line segments in our different quadrilaterals are either parallel or perpendicular to make those 90-degree angles. So remember, a rectangle has 2 pairs of parallel sides and 4 right angles. So for each of these shapes, I'm going to check those pieces to see if they are truly rectangles. So here I would want to see if AB is parallel to DC first. So looks like A is at point -4, 0. So this here is -4, 0. B is at 1, 2. And if I want to calculate the slope, I know we can't see the grid very well. So I know to get from 0 to 2, I went up 2. Use a different color. I'm going up 2 as my rise, and then I am running from -4 to 1, so I'm running 5. So this side here has a slope of 2/5, and I'm going uphill, so it's positive. And then I'm going to check D to C to see if it also has a slope of 2/5. So D is at -2, -5. C is at 3, -3. So you can make a triangle that way, or we can go this way if you want to have it match the one above. So I can see again I'm going up 2, so from -5 to -3, and then running from -2 to 3 is going over 5. So my slope again is 2/5. So I know that these lines are parallel, and I can prove it with these slopes. Then I want to also check that the other sides are parallel. So BC and AD. So if I make a slope triangle, so this is going from 1 to 3, so I know I'm going over 2. And then I'm going from 2 to -3, so down 5. And then be careful that we're watching for direction first. So as I go left to right, this is sloping downward, so my slope is going to be a negative, and then my rise over run is 5/2. And then I'll check this side. So make my triangle. So I can see from 0 to -5, this is 5. And then from -2 to -4, this is 2. And again, it's sloping downward. So this has a slope of -5/2. So I can see that those lines are also parallel. So I've proven the opposite sides parallel, or two pairs of parallel sides. And then I can also see from those same slopes, so -5/2 and 2/5. One's positive, one's negative, and the rise and run are flipped, so 2/5 versus 5/2. So I know, so I've met opposite sides parallel. Make like a little checkbox. Check, and 90-degree angles. Oops. Sorry. 90-degree angles. And we should verify, so because we've also, that happens here, this is 90 because those are perpendicular, and then the 2/5 -5/2 makes that 90. The -5/2, 2/5 there makes that 90. And then last one, 2/5 -5/2 makes that 90. So we do want to technically check all of them. So this is indeed a rectangle. All right, and then the second example, so K is at -2, 3, N is -3, -2, 3, -3, and 4, 2. So if I want to check parallel, opposite sides parallel. So over here, we're rising from -2 to 3, so that's 5. And then from -3 to -2 is 1. So over here, I have a slope of, so it's going uphill, so positive. Rise over run is 5/1. And then my rise over run here, so from -3 to 2 is another 5. And then from 3 to 4 is 1. So this also has a positive 5/1. So I know those lines are parallel. Then we'll look here. So I see this slope is negative. And it looks like it's going 1. So 2 to 3 is 1. And then -2 to 4 is 6. So this is rise over 1, -1/6. And then down here, we're going from, let's see, -2 to 4, so it's also 6. And then from -3 to -2, so that's 1. And this is a negative slope, so -1/6 also, so I know those are parallel as well. So we've met the opposite sides parallel criteria. And then now we're going to check for 90-degree angles. So in this case, we see, so this line here had a slope of 5/1, but this line here had -1/6. So since those are not opposite reciprocals, okay, so this 5 and this 6 are not the same, that means that we have not met the second criteria, and I cannot say that these are perpendicular. So this is not a rectangle. It is, however, a parallelogram because I have shown that opposite sides are parallel. It just doesn't have 90-degree angles.